Alright, hey everyone. I've been mucking around with something called the distributive law, which is it's a way of expanding an algebraic expression. So we got some values here, and I'm going to show you how it's done, and we'll practice it a couple of times, and then you can try it on your own. So this is the law. So we have here A, open bracket, B plus C, close bracket. And we want to know, what does that equal? Now, just so you can see where things are going, I'm just going to color code these. If you give me a second. Just so then you can see the difference between these values here and where everything's going. Alright. Now the process of distributing a value only occurs when you have a value outside of the brackets and there is not a plus or minus sign in between them. Right? So there's no plus or minus sign in there, which means, as you should know from all of our other algebraic practice, that it means that there's a little multiplication sign in there. Right? So we're saying that A is multiplied by whatever B plus C is. Now, sometimes you may be able to just solve B plus C if they're actual values, like 2 plus 4, for example. You should be able to solve that as 6 and then times it by A. However, algebraically, if we don't know what B and C are, then we can't do it this way. So let's have a look at what we can do, right? So if I'm multiplying one value here, so multiply the A by both of these values on the inside, not just one. Okay, so rather than plus them together and times it by A, we individually times both of these values by A. So let's have a look at what that looks like. Well, we have, our answer should be A times B plus A times C. Alright, so I'm just going to color code these again so you can see how that where everything is gone there. So A times B, A times C. Alright, and that gives us a good indication of where all those values are going. Now with algebra, keep in mind, if there is a multiplication between two letters, we don't have to write that multiplication symbol in between, so we can just write them as AB plus AC. Right? And again, just so you realize where everything is, I'm just color coding these, just so it helps you. All right? And now I've got this solution here, so AB plus AC. And now the question is, are these like terms? Can I plus them together? Can I do anything else? Well, hopefully you've looked at that and gone, well, no, they're not, because there's AB and AC are two different values, because the B and the C are different, regardless of the A being there or not. So let's try with an actual example and see how that goes. So I'm going to follow the exact same process here. So I've got 2 multiplied by x minus 4. So again, I'm going to do 2 times x and 2 times minus 4. Okay? So I have 2 times x, right? And what I should get into the habit of is actually just leaving this value in the middle here. So I'm gonna leave that value in the middle there. I'm gonna have 2 times 4. All right. And now if you were going to take the minus because it's a minus 4, you could do that, but then this value here would have to be a plus. So we're not going to muck around with that too much, otherwise it's going to get a little bit confusing. Now let's color code these the same way so you can see where everything has gone. Alright, there's the 2, x and 4. I'm just going to add in another color here, which I have somehow misplaced. There we go. Just so you can see that this minus symbol has also moved to here. Alright, so that's going there. So let's have a look and see what we've got here. 2 times x gives me 2x minus 2 times 4, which gives me 8. So my answer is 2x minus 8. Alright, no problems. Alright, well let's look at another possibility. Okay, now this is, I want you to pretend that this is a worded problem here. When I say that I have a piece of lawn, right? Let's say that this is my backyard, okay? And the measurements are 4 meters by something. I can't really remember what the long side is, so I've just written it in as an X at the moment. Now, at the end of my lawn, I've actually added some more grass, right? So I've added some more grass in a square that is a 3 by 4, so it's the same width as the rest of the lawn, but it's just an additional 3 meters that's been added onto the end. Now, the question being, how could I find out the size of the lawn? Okay, and obviously there's an unknown in there, so we're going to try and find it and simplify and distribute the easiest way that we can. Now, from memory, you got to think back. The equation the formula to find the area of a rectangle is whatever the length is multiplied by whatever the width is, right? It's length times width. So that's the formula here. Now we can do that. We have our length, which is 4, right? And we multiply that by our width. Now our width is whatever this value is here, plus this additional 3 meters. So I'm going to put that in brackets here, x plus 3. You might be like, well, why do we put it in brackets? Right, because the alternative, so I'm just going to write this over here because this is wrong, would be 4 times x plus 3 like that. And as you know, you do BidMaths, you would be finding 4 times x, which is this area in here, and then you would just plus an additional 3 meters on, which is incorrect, because this is actually a 3 by 4 segment here, right? So that's why it's in the brackets, okay? Now, all of a sudden, if I get rid of this multiplication sign, we're looking at the same problem as above, a distributive law problem, all right? So again, I can do the exact same thing as I did previously. I'm going to color code in my numbers here. All right, color coded in some numbers here. And again, I'm going to do 4 times x and then 4 times 3. All right, so 4 times x plus 4 times 3. All right, and that's going to find my area. So 4 times x can just be rewritten as 4x plus 4 times 3 gives me 12. All right, so I'm going to color code this in as well, just so you can see what I've done here. And I just want to show you why this formula makes sense too. All right. So basically we're saying whatever this formula is, or whatever this area is it's 4 times whatever our x value may be, plus an additional 12 square meters on the end. All right. And that starts to make sense when you think about it, because this is 4 times x is the perimeter of this perimeter. So the area of this little shape here, and here, well, this is a 4 by 3, which gives us a 12, right? 12 meters squared. And that makes sense. 3 times 4 is 12. Therefore, it makes sense that that last little bit will be an additional 12, and it makes sense that we're adding 12 on to our 4x, which is what happens if you times 4 and x together. 4x plus 12. Just so you can see how that all works. Now let's look at another scenario. We've got x plus 3 open bracket ab minus 10. And I wanted to show you this one because I wanted you to keep in mind how things work And this is a common thing that people make mistakes with as well. So, all right, so the x just stays put. I'm not going to touch the x. Plus, now we're going to distribute our 3 to these values here. So x plus 3 times a. Remember, AB means a times b. So 3 times a times b minus, so I'm keeping that sign in the middle, 3 times 10. All right, so let me show you where everything's gone. So we've got our 3 there, our A and B are both there, and our 10 is there, which means that our x has stayed put, right? And so has our minus sign in between. They haven't really moved, they're just in the same spot again. So now let's collect the like terms amongst what we got here. And again, we have x plus 3 times a times b is 3ab minus 3 times 10, which is 30. All right, and I don't have any more like terms there because all the pronumerals here are different. All right, let's look at one last one. So this time I've got negative something, open bracket, n minus 22. Might be like, well, what's this negative value? What does it mean? All right. Well, this is something that we come across in other areas of algebra, but we haven't really looked at this before. What do we have if there is nothing before a pronumeral? In this case, we have nothing before a bracket. Now keep in mind, see with this x above, if I asked you what the coefficient is next to that x, hopefully you would tell me that it's 1, right? Because 1 times x is just x. Similarly here, if there is no value next to the bracket, we're going to assume that there's a 1 there. Okay, so now let's do this working out here, and we'll distribute this negative 1 and see what the results are. Now it's important to know when the negative value is on the outside, it is extremely important that you write it, that you bring that value with it, because otherwise you're going to make a mistake. So I'm going to have negative 1, which is our value on the outside, times m minus, and now we're going to have negative 1 times 22. All right. So negative 1 times m is just minus m. All right. Minus negative 1 times 22 is minus 22. Alright, so I've got negative m minus 22. And remember what happens if there's a minus and a minus together? Thinking back to directed numbers, if there's a minus and a minus next to each other, we can replace it with a plus and it will function in the exact same way. Yeah, so that's our solution there. Okay, I hope that you found this useful. If for whatever reason you're stuck, feel free to go back and re-watch the video again. Maybe go through these on your own to refresh your memory at the end of this. All right. Thanks everyone. Have a great day.